about me. I don't profess to be necessarily an expert, but maybe I've done this more than you. Who here has like zero experience or minimal experience? Okay, so that's pretty good. And then I'm assuming generally in between is generally in between. So pretty good mix though overall. So cool. You're good to go? Okay. So yeah, I mean, intro to, right, who am I, why do you care? I recently graduated from Pitt with a bachelor's in computer science. Yay. I used to be a NOC technician. That was like one of the internships I did. So some of the hardware stuff kind of went along with that more than, not everything we're going to talk about tonight is just software. I don't have a job, so I'm going to find one, I hope. But I'm basically a hobbyist in this area. A couple of my friends and I started like a group. One of them's like a finance guy. He's in business, and so he was paying attention to like the markets and stuff like that. When are we going to sell what we've actually mined? What are we going to do with it? That kind of stuff. Whereas so we each kind of have some different areas of expertise that we try to go about it. If you're interested in stuff like that, maybe that's the way to go about it. So yeah, we'll just kind of start out so we all have like a basic understanding about like the blockchain in general. What's the problem here? Why do we need a blockchain? I guess there's always, money's always a problem, but realistically, lots of research was done by people that I don't really know, and I've done some research on, but I don't have, all I have is the internet to go on. Basically, like a lot of distributed ledger systems, have problems in general. Banks that try and communicate with each other, that want to say, if I transfer money to you, for example, then how long does that take for the bank to actually verify it? We've all kind of experienced that in the aspect of like, if there's a $2,000 or something transaction, they'll make you wait, I don't know, 2 days, 3 days, some amount of time in between. That time period a lot of the time ends up being verifying records between databases, shared databases, double records, lots of fun stuff there. Also banks obviously probably want an audit trail, right? They want to know where money is rather than just let it go somewhere. Not a huge surprise, but lots of networks have lots of nodes or network nodes. So like the pretty assumed typical infrastructure. But a lot of the banking software, I don't even know what stuff it's on. People just say like, old or mainframe or for some banks, and I'm sure some banks are, upgraded to newer software or a newer infrastructure, but, not everybody. So if you're trying to communicate between one bank and another, maybe more delays, maybe less. Double spending being a big problem. If I give you money with cash, right, it's only that money's gone now. I don't get to keep it anymore. But with like digital currency, if I want to give somebody money, what happens until that's verified, right? That same problem that we had. If it takes 3 days to get into your account, can I still spend that money in between? Kind of the concept of like floating money. I don't know. My mom's floated a check before, so I don't know if anybody else has done it or has parents that have done it or something, but kind of the same concept there is that, spending money essentially that you don't have. And then obviously centralization. So we kind of talked about like the shared thing. Where's it coming from? Who's going to care, or who's going to have the definitive database record, for example? Therefore a particular authoritative source. So a solution in some ways to that problem, enter blockchain. So why I have like a chicken or egg question, being that like a lot of people associate, a blockchain or like the blockchain. In fact, my friend that is in finance just said, invest in blockchain, and we were like, well, which one then? And so a lot of people don't necessarily know that like a Bitcoin is separate. So that's kind of the first part. Otherwise, blockchain being essentially the best way I would describe it is a foundational technology, and on that basis being that like it is something that other things are built on primarily, or it can be built on. So what does a blockchain consist of? Basically, blocks, transactions or data. Blocks being the primary function or linked list nodes, kind of, and typically some kind of cryptographic nonce, timestamp as we see here, Wikipedia image, not a huge deal to find something, but we also see like a previous hash, the idea being that like there is some linked nature, that things have to be calculated between each one of them. It's just kind of like a general idea. I don't know if anybody wants more information on that, but feel free to ask questions if you guys have them. So we talked about centralization being a problem. Decentralization, is essentially the staple, or a lot of people, second thing you hear about a blockchain is probably something about decentralization. So fundamentally, if you partially trust, everybody, or assign kind of the same amount of trust to everybody, then it's not just, Credit Suisse that, I don't know if I'm pronouncing that right, but that, owns the authoritative record versus each one of us in a blockchain that we might share. So partial trust is useful as far as decentralization, because then we all have kind of the same record. That's kind of the fundamental bit there. And then as we've kind of shown here, so we have block 10, previous hash, timestamp, etc. The stuff that can go, and a nonce that can go into our next block. When we actually want to change the record, or create transactions, as we have in kind of like the transaction 0, TX1, etc. So these aren't necessarily, these can't necessarily be reproduced. They're kind of it's the only thing that can be there, unless you were to go back and reproduce everything from there on. So if you said, I want to change block 11, you're probably going to have to change block 10, 11, 12, you definitely have to change 12 and everything beyond, right? So so anything that you want to go from there, if you were to say we're on block 30,000, you want to change block 12, well, that's a lot of work that's going to happen, right? So there's a big difference between that. Kind of the biggest, I guess, to me, part that's like makes it secure is there's just a lot of work. Since it's decentralized, since it's distributed, then one individual probably can't do that much work, right? I kind of mentioned this, each member being equally trusted, kind of the fundamental part of it being like a partial trust agreement there. Where am I here? Okay. So some problems that kind of have at least been observed, documented, some of them at least. Hackers, I think everybody's heard of something being hacked. I think one of the more recent was one of the currencies like NXT had to execute like a hard fork, so had to get rid of a bunch of blocks that they had in order to get rid of like a ton of records that had been hacked, and basically lots of money lost otherwise, or lost. So otherwise, like the concept uncles, cousins, orphans, this is something that's difficult for me to understand, a lot of people probably to understand. We find a number of blocks, what are these things, right? So as we come along with stuff, well, essentially if we're going to look at like an uncle or a cousin or an orphan being, if I can find a particular number of blocks, right, and I'm going to submit those that they'll be verified, then there's probably more than one that are going to be valid as far as the next one, but they're not necessarily all selected. So we end up with these kind of like literally orphaned, which is why they say it, orphaned blocks that maybe are used or maybe just aren't. And so that can be a problem. It also can just be a problem for understanding. So forking, as I mentioned, there being not necessarily always a problem, but can be a problem for you if, for example, you were on the wrong fork and you lost your money out of there. Typically, development communities around a particular currency will try to avoid that. So it's not a huge problem, but it's something to be aware of. Also, I kind of mentioned generally that you'd have to kind of redo all the work. So the like greater than 50% attack being that like if you have the majority of, I guess, the recent blocks in the blockchain, then like you kind of own that blockchain. So you could say this is the next block. It being a distributed system, the idea again being like everybody's an individual, or theoretically, but then if you had like a group of 51%, then like that group could essentially like make a hostile takeover of a particular currency and say this is the next one. What's hostile? I mean, I guess I would compare it to like a Linux, hostile takeover to say this is the direction that an open source project is going to go, rather than another one if enough of the community is going to follow one way or another. A lot of the other, kind of documented problems kind of fall into the category of like a confirmation bias, or kind of goes back to the double spending problem. So how soon can we say this is a verified block and it can be used for spending? And a lot of those rules are dependent on who's awarding the blocks and verifying them, etc. So most of the time it's like there's a situation where if you just mine this block and you gave it to one person and then they executed it, it's trusted, and therefore we don't know that you actually double spent that. But problems that either are documented in such a way that like these are less than a 1% chance or something like that, right? They're not necessarily huge problems, but they are problems. Other ones, so one kind of open problem, I guess now, is that people are talking about that they believe there might be one, all these different blockchain technologies, all these different currencies might end up, on one blockchain. If so, which one? So that's just kind of an open question. If you guys are looking, thinking, whatever, think about it. Also, is a blockchain even useful to you? A lot of people, it's one of those buzzword type of things. If I'm a company and I'm looking for it, which I'm not, but then why would I want to build one? Why would I want to use one? Why would I want to actually grab anyone that's out there and use it? And then exactly what the cryptographic security of each one is. A lot of these are based on similar algorithms, and some people believe for some of them they're more and less secure than others. There's like the concept of like a private or a public chain, and I'm sure you guys have heard like Bitcoin was used or is used for like buying something on like the dark web or something, and so like the necessary traceability of each one. So that kind of all goes into like the cryptographic nature of each particular currency or each particular algorithm. So
in the previous slide, you at the bottom you had this R3.
Oh yeah, I missed that. Thanks. So other efforts, R3, a like collective of, I think it was like 42 banks primarily, and then they made like kind of a brain trust, really just an exercise, like a thought exercise about like what would be. They charge this brain trust with finding the right blockchain for banks to use, and so they actually went through and analyzed a bunch of them, and very quickly we're like, well, I don't know if it's really a blockchain that we want to use. And so they ended up coming out with Corda, which is an open source project. I haven't looked into it a ton because it wasn't something that was particularly interesting to me, but what I understand is that basically it's another distributed ledger system. So it was kind of like they believe that blockchain just maybe isn't the right one that's out there, or maybe it's just not right yet. I think a major part being that everybody wants to have some kind of ownership or authority. You want somebody to blame, right? So and a bank not having somebody to blame, that might not be the best situation for them, or maybe they're just not desiring that. So that's all I've got on like kind of the basic blockchain stuff. Just kind of quick questions or anything.
So you have like all the blocks. About how much data can you fit into a block? Does that hold like all the records of who owns what money?
Oh, so let's go back to this guy. So we kind of see the best example here, but so we have like a previous hash, and this one will go in there. So they're linked to each other. Some algorithms, some currencies, some blockchains, if you will use different algorithms on how they actually do that. So some of them will link between like a block to block, so you're kind of going through to see where the origin of it was, and so you have like more and less trust in any individual like Bitcoin. Right, and so other ones will have different algorithms where maybe there's another data piece in here that has like, this is a 1 or 0'd out, has this been spent or not, or something. That I'm not 100% on, but they don't always expose that stuff, so I can't give you like a perfect answer. If you have something else to say, I don't know. But yeah, so otherwise, as each transaction is logged on each one, that transaction record essentially would be like, you could look through the record of transactions over the course of all of the time that that blockchain's been active and find the origin, like this, I'm actually spending from this block, but that would probably take a really long time, so.
The follow-up on his thing, this distributed ledger thing is very interesting besides the money perspective. For example, I don't know, I'm Johnson & Johnson and I want to be able to track each bottle individually. How it goes through all the stores and so on and so forth. Because Johnson & Johnson manufactures it, it has end distributors, and then there's a bunch of small distributors, and it finally gets to the thing. And what happens is all these people don't want to share information, but they want to charge each other for information. So this distributed ledger thing is interesting because I don't know if it could be used to track each bottle of aspirin individually. So to piggyback on this question, what other information besides having an integer or a decimal which corresponds to money, can you have other data besides money in this distributed ledger?
Yeah, so I mean, there's no reason that you couldn't necessarily, and I know that I'm not 100% on this application, but I do know that it has been considered for supply chain applications. Okay. So I'm not sure if it's like you would assign like a nominal value or like a canonical value instead of like block 10, right? You might say, I don't know, a Johnson & Johnson product, but baby powder, right? So, and you might say baby powder, and then your nonce or something be a unique identifier for that particular one.
Sure. And
maybe be able to track them through there. Exactly how to do that, I'm not sure, but I do know that it's been considered that it could be a practical application for like a full supply chain implementation. I don't know of any particular platform that's done that yet.
Yeah, sure.
But I know it's been kind of like a discussion out there, so. Anything else so far?
Can I ask one more question?
Yeah, of course.
How many nodes, if I ask too many questions, just tell me to shut up. How many nodes do you need for this to be viable? What's the minimum number of nodes?
So I guess that would be a really good cryptographic question.
More.
Yeah. So many of them have. I mean, 12 is a really bad example. Most of them that you look at have. At least over 500,000 or something already, and that's usually within the first few days of them being created or so, or at least weeks or so. I don't even know offhand what Bitcoin's at, but I do know.
Blocks or physical nodes?
Physical nodes.
Server,
Oh, okay.
I'm sorry, thank you for correcting me. That's exactly what it is. I mean, if I have 100 people on my network, can I do this, or do I need at least 1,000 people?
No, so I mean, any individual could actually be a part of a particular blockchain. That's kind of the benefit of it being a distributed network. You don't necessarily need to have a network of 1,000 computers.
But how many people?
If you want to
I think he's referring to building a private blockchain.
Oh, okay. Yeah. Lots.
More than
A lot. Probably lots of servers designed to do this. Yeah, because the point being that no individual, no one device could actually do it on its own, or it would take a really long time in order for one individual to do that. I'm going to kind of skip ahead in that area. Sure. Two companies have kind of a service. Microsoft calls it blockchain as a service. IBM, maybe it was platform as a service or something like that. I don't remember, but basically they both have virtualization platforms, and so I'm assuming on their virtualization platform they're spinning up a bunch of VMs that help you build this blockchain quickly. What exact algorithm they're using and what blockchain they're necessarily using, I don't think is released, so they could not be using a proof of work algorithm, but that's kind of skipping ahead. Anything else? Okay. Okay, so cryptocurrencies, generally, like I said, kind of moving a little bit off of what a blockchain is, more about what this is in with respect to money, right? And so, early days. Some of this stuff too is also researched. I didn't have anything to do with anything in 1990 to 98, for example. But so DigiCash was an effort that Microsoft almost bought out. That was just on a cryptographically secure digital currency that ended up failing, but that was nice. They tried. BitGold was a concept distributed public registry. So instead of it just being like a distributed ledger that was between private parties, this be something that everybody could potentially use. That's a pretty big component there. Using public key security, which is kind of still what we're doing. So or in many instances, and that at least what Bitcoin started using. And then a distributed network for new coins and a particular timestamp. So this is the accepted coin that we're going to use, or the accepted token that we're going to use. Bitcoin 2008, kind of a fast forward. The first currency that was created started being used or anything. Pretty much a step on to BitGold, but an actual implementation. So guess what, they win. Other early ones, Namecoin, shortly after Bitcoin. There are still .bit domain registrars. So the idea being that Namecoin could decentralize DNS and help to prevent online censorship, so you could use their blockchain in order to host a website, use a .bit domain. Good. Litecoin is another one that a lot of people have heard of if you've heard of Bitcoin. Non-SHA based proof of work algorithm, used the script algorithm. Honestly, I guess to me it was kind of like, hey, it's not Bitcoin. So.
Just wanted to chime in. There's one very notable exception there between BitGold and Bitcoin. There was one called Hashcash that introduced the concept of proof of work, more so than DigiCash and BitGold did. DigiCash put on the idea of using encryption in some way to secure transactions as they were passed from person to another. BitGold added on this kind of registry of public and private keys, kind of like the PGP system, and introduced the concept of creation of new money, an inflationary period. Hashcash was the one that said, hey, we've got this way of making sure, automatically making sure that new currency is added to the available pool, but not too quickly. And Bitcoin descends significantly from Hashcash, and that Bitcoin very effectively solved the problem of the right proof of work algorithm to use, as well as how to propagate blocks around. Bitcoin to me was more of an innovation in that space of how to propagate transactions than novel things like proof of work hashing for proof of work and whatnot.
Okay. Thank you. I didn't know that existed. So, okay. So I kind of not necessarily in order, but I felt there was more. It felt better this way. So cryptographic exchanges. Most of you probably know what a currency exchange is. Just going to draw the comparison there. So a lot of these we're used to being brick and mortar. Obviously, they're also online. Many of them for a long time have had fees. They're kind of starting to trend towards like, no, we just give you this much money for that much money, and they kind of build in their fees. So they do set, and this is the kind of important component there. They do set whatever their exchange rate is. For example, if you went on like, I don't know, Google or some other source to find an exchange rate, the exchange rate you'll see there is probably vastly different than whichever one you go to the store and you see and you actually get. I just looked at like the euro today, and it was like 89 versus like what you actually would get was like 80. So like per dollar. So it was like, it might be the opposite way around, I can't remember. But the point being that like you would get less from the actual exchange typically than like the theoretical exchange rate would be. So cryptocurrency exchanges, online only, not a big surprise there. Basically the same model otherwise. Probably stricter on fees generally. There are a few that don't have them. Lots of potential problems around there. There's a lot of cryptocurrency exchanges. Which one to use becomes a big problem. So as I mentioned, because there are different rates, maybe you want to be using a different one. Could be day to day, could be more consistently or less consistently. How long does it take to complete the transaction? Some of them are very short amount of time because they're actually pulling block pairs really quickly in a particular market. Other ones are taking days, weeks. Sometimes it simply takes a day or a week because your transaction, I guess, got lost. I'm not exactly sure what happens sometimes, but seems like people get pretty pissed about that because your money's in limbo for a while. Development support changes. Coinbase, probably the biggest example of that. That it doesn't appear that anyone's actively developing on that exchange anymore, so people are kind of worried about that now. Although it's still a pretty big exchange, so maybe it's fine. They're just done. Who knows? Customer support, again, really variable. One of them, the customer support is like a message client, and that's all you get. And hopefully a bot returns your message or something. Others, there's a number to call in. They're all over the world, so it could be that the one that you're using is in Germany or Hong Kong or San Francisco, and so there is kind of an unknown level of what kind of support you're going to get from any of those. The particular market volume, which goes back to kind of the time to complete your transaction, how much are they actually trading in that, so when's your transaction going to complete? And then what are you trying to trade? Are you trying to trade a bunch of different coins, or are you just trying to trade Bitcoin to USD or something to that effect? And then just as a general note, because I didn't find really a better place to put this, but fees are typically like a 1 to 2%, some are less, some are more for each currency. So just kind of a list here to show that there are a lot. No particular order, so don't say Erik said something. But the ones that I have actually used, Poloniex and Kraken, the top two, and I mean, those have both been fine. As like Poloniex, as I mentioned, I haven't had a problem with, but it's only got a message board if there was a problem, so hopefully I never do. But yeah, lots of them. This will be shared afterwards if you guys want this list for some reason. My recommendations, as I mentioned, kind of disclaimer, the few that really stick out, generally Poloniex and Kraken, as I mentioned, I've used and have some trust behind. OKCoin, Bitfinex, Bitstamp, Bittrex, etc. So some of these have more or less coins that they actually trade on. Poloniex has a lot, and they have like market data that you can look at, so you get like the charts, limit order book that you can see, so if there's something that's going to be bought. Like stock sales, if you want like to place a limit order, or if you want to place a stop order, you can say I want to buy at this particular price, or I want to sell at this particular price, rather than putting in like a put order, rather than it being just like, hey, give me money, hopefully, and so there's some of these, like I said, have more and less tools that go along with that. One of the ones that I saw that I haven't used that looked interesting was OKCoin. Their rates were really good, so that's good. Also, they had no fees, so that was pretty rare to see. Bittrex also had, I think, like 0.25% fees, so maybe I'll start using that. I don't know. Again, don't trust me. This stuff changes potentially every day. So one place that is a pretty good place to start is that link down at the bottom, cryptocoincharts.info, markets info. It's also not, like I said, authoritative source for anything. So take a look on what you're doing, pay attention to what you're doing. Don't just hope for the best. It's your money, if it is money. Currencies, lots of them. So BTC being Bitcoin, there's just a ton of these guys out there. Lots of different purposes for them, lots of different values for them. Bitcoin obviously being the big one. I did have a couple that are out there because I just want to kind of make the major point that you've probably heard of a few of these if you've been looking around at all. It's a smattering of many of them. There's certainly more than these that are out there. Some currencies last for like a day, a week. Some are entirely, there for no reason. These are all fiat currencies, right? Like there's no, basis of these behind gold. So, somebody could make this for no reason, have 10, blocks on a blockchain because they were like, this is cool and I love it. I don't know. You could put out your own coin and start it and put it out there and people could potentially trade it, I guess. But quite unlikely that I guess they would, gain traction. I've got 3 on the top there that are my favorite examples of ones that either have gone defunct or I find no real purpose in. PNC is like the porn network coin, so you're supposed to be able to buy porn online with it, I guess, and that one's now gone defunct, so I guess you can't anymore. Pot, not a huge surprise, you're supposed to be able to buy pot with this. I'm not sure if it's online or what the point is. That one seems to be live. I'm not sure that it doesn't have much hash rate though, so I don't think it's really that great. Nyan or Nyancat is alive and well. Reddit loves this one, so people still are participating on that. But yeah, otherwise, there's a bunch of other ones that are there. Other than giving you, maybe just like a general idea, being like, what they are. I don't know all of them, even myself, or enough about all of them to, say much. So instead, I've gone with some currencies that I consider healthy, and feel free to chime in. But again, disclaimer, my opinion only. So, and obviously, generally, I haven't valued these by anything other than what I've noticed in the course of as I've gone about mining and trading and whatever. So, most of these have some relatively nominal $10 or more, USD value to them. People typically, ones that are around that level, typically people have some kind of trust in. Bitcoin, obviously, being first, Ethereum, being a secure application platform. Recently, some companies have adopted their application platform, so a lot of trust has gone in there. Ethereum's gained a lot of ground recently, so they used to be trading at $6, and now they're at $2.50. So those are probably the places if you're looking to try to buy currencies that you're hoping to get that. Probably one that you missed the train on. Litecoin, definitely lower, but Script again being something that they tried to make a different algorithm. Zcash, I honestly don't really get the point of Zcash, but it's trading pretty high, so I guess that's a good thing. NXT was, I mentioned before, had a hard fork. People seem to still be into that one, so. Yes?
They didn't actually hard fork the cash back at NXT.
They didn't put the cash back in
back in exchange. No, Ethereum had a hard fork though. And,
yeah,
and
for ETC.
That's the big one when they But NXT didn't end up hard forking. The thief, I think, stole from Beater exchange and got away with 5 million NXT, which was 5% of NXT.
Okay. Monero, also I've got some algorithms there. We're going to talk about that in a minute, so I'm kind of glossing over that for now, but just so that you can see them together. Monero seems to be untraceable, or that's kind of its moniker they're going with. Dash, I guess interesting part there that I saw was they still use master nodes, so there is more trust in some nodes than other nodes. So you joining their network might not be any kind of necessarily authoritative source, so that might be something banks are interested in. Factom uses NXT and Factom both use proof of stake models. We kind of glossed over that earlier too, but we'll talk about that in a minute. So kind of currencies in general.
Do you know of any that don't have like any actual people controlling them? My thought being that, like, say, a worm or virus could install. I've heard viruses turning machines into Bitcoin miners. Is there a network of, maybe like a zombie cache network that's out there that spreads itself to run a mine or something like that?
Oh, so like somebody started one and nobody actually like participates in it?
Well,
but, like,
it would be
it's
something
just-
that like people aren't choosing to participate in, but
Right, yeah.
like the people that want to use it could still do transactions on it or something like that.
Not that I know of. The only ones that I've heard of as far as like there being, pervasive virus on was Bitcoin. And, that being just, creating botnets for, to do mining. I haven't heard of that happening lately because, essentially, you're taking a big gamble on what computer you're going to connect to and if you're getting any like useful hash rate anyway. So I think it might just have kind of, at least in that market, gone out because it doesn't make you much money on that. So it might be more effort than it's worth now, but or maybe they've just been squashed. I don't know. But that's the only one that I've heard of. It, you guys?
I mean, there's still value in it. You can extract value from the slowest processor in the world, mining on the slowest processor in the world, as long as it doesn't cost you anything to purchase that equipment or to power it. If you had every Raspberry Pi ever made mining on the Bitcoin network, it's going to eventually provide you some value someday.
Yeah.
It's going to, a very, very slow trickle. You generally don't see a whole lot of mining worms out there anymore because it's simply not practical. For the reason that I just kind of explained, like people don't see it. What's more practical is ransomware type stuff. And that's the kind of thing you see more often in news, especially.
There was one recently, right?
Yeah, I think it was 3 weeks ago. Was the NHS, British NHS system got hit with stuff. WannaCry, yeah. And that's what you're going to see more often because it's a whole lot more easy. It's a whole lot better to get money out of that to just like ask somebody for a little bit of money than to turn their machine into something that's just going to get you maybe a dime over the next year and burn through their power bill.
Yeah, might destroy the system before getting anything useful. Other questions for cryptocurrency stuff? Okay. So yeah, mining. General kind of history via hardware. Just to, again, my understanding, because I haven't been there the whole time. So as we kind of just talked about, CPU is still efficient with some algorithms, more and less with others, but not typically used anymore. A lot of algorithms started with it, Bitcoin, Ethereum, many of these algorithms start with CPU just because it's available when they're doing any kind of like proofs on it. They typically use some kind of like standardized CPU, publish papers, and then actually build whatever blockchain it is. Graphics cards, I actually started just using the card that I had in my computer, and I got like 2 Ethereum over like a month and a half or 2 or something a while back, and I mean that was good, but it was $6. Also, I didn't have to pay for power at the time, so that was good. But probably not necessarily that useful as far as like how much money you're going to make versus what power you're actually expending. Lots of GPU rigs that are out there for different algorithms that are still basically on memory hard, because you get memory on a graphics card. You have a certain amount, typically way more VRAM than you need, and then you have a processor that's dedicated to it, so you don't have to really worry about it. Also, graphics cards are way better at matrix algebra, so they do a lot of this stuff just faster anyway. Not all of the algorithms are necessarily lend themselves to graphics cards, but a lot of the ones that you might build a rig for are today. hash rate's hard to talk about for graphics cards. Again, depending on the algorithm, etc. Could be a small amount or the quality of the graphics card. Some of the top end ones, run hundreds of hashes on, some algorithms or mega hashes, and others might be way less. But in comparison, there was kind of an in-between. This is, I guess, skipped a lot. I never saw any of this. What I honestly have researched about FPGAs is really, just that people wanted to use these to, get gains between either CPU or, GPUs, typically, in order to get a specific algorithm going.
I was going to say FPGAs they do about the same hashing as GPUs, but consumed like a tenth of the power.
Okay.
So for efficiency, but they were also much more expensive in a lot of cases. So.
Cost you less
But
money.
they also are the stepping stone for developing your next one.
Yeah. And that's exactly what we've got there. So ASICs are application-specific integrated circuits. A lot of these are on SHA-256 or SHA-2 algorithms. Oh, damn it. I forgot. I actually still have a couple of the USB block-eruptors, but I can't pass those around, so sorry. Because I forgot them. Yeah, so I mean, little USB drives that were basically just a little circuit that did, what you want, go through whichever based on the algorithm that they are. Typically, they just had some kind of piece of metal on them that would be how you're going to dissipate your heat, which is not really very efficient. A lot of guys that I know of, used them just in open air setups and stuff too, which also isn't really a great way to cool a device that's going to be generating any power. But at least because they're USB based, there's a limited amount of power that they can actually draw there. That I've seen people that actually use them were always using them about 3.5-ish gigahertz per device for Bitcoin, which if we see with the Antminer S9, I think it's 11.9 terahashes per second. So completely antiquating, and on top of that, the power amount that these specific devices are using compared to USB devices, it doesn't make sense to really use them. You're not going to be able to generate essentially enough hash rate on Bitcoin that you'll really get much of anything, or you'll probably be paying more in electricity than you will be making any money on. And then cloud mining and mining farms. So there are some of the some blockchain currencies or groups provide this as a service. I guess it's maybe a way for them to make money too. Other places are kind of consulting places that they provide. They probably have a data center somewhere. Typically, it's always been that I've seen they have a farm or a data center somewhere, and they're just we'll give you this hash rate, and you'll get that much, whatever the contracts that come out of that are. I don't see a ton of value in that, but obviously cloud mining, as I kind of did the spoiler with IBM and Microsoft, maybe that's something that's useful as far as a private application. So I don't know. So GPUs are rig design. Obviously, I have this guy, so kind of have to bring that up. Some of the GPUs to use. A lot of guys are using AMDs. They seem to be, just give you a better hash rate per power for most algorithms. Most of the ones that I've seen that are running that, Ethereum, Zcash, Decred, but just because of the one. Open air rigs, like I said, this was actually the first rig that we built with my friends and I. Not anything special, just in somebody's garage or somebody's basement, so it didn't get too warm, and it was pretty, cheap as far as cooling down there. We had a lot of problems with overheating still, and so I still wouldn't recommend this, but it's up to you. I would stress that you maybe consider airflow for that reason. What power requirements you have, just because if you have so many of these are typically what's going to take up a lot of power. If you're building a system in general, you kind of always have to do that. Like I said, case or not, I would recommend a case, but that's fine. Adapters with a case is sometimes a problem because your case might need specific ones, so be aware. OSs that I've used so far, not all, I haven't used EthOS, but Windows, Linux with Xorg are the two that I've used so far. This one actually runs Linux, that one we ran Windows on. And both of them haven't been a huge problem, as long as I've had a system with either Windows or Linux on separately while I've built either one, so I didn't have a problem because I had to set up GPUs for this guy. I had to flash them on a Windows device, but then I could use more of them on the Linux operating system, and I could directly plug them in, and I got faster hash rates. So, if you have more than one system, do whatever you want. If you have more than one system and one of them is Windows, probably use Linux. If you only have Windows, use Windows. So just kind of an open, these take power. And if you run a gaming computer at home, and you've paid an electric bill, and you run it all the time, and you don't run it, then even like I said, with the difference in just running my graphics card in my computer, I saw a bump in my electric bill. It wasn't really significant, but when I run this thing, I do see a $10 bump-ish. Not huge. It's no worse than, I don't know, in the summer when we run the air conditioner or something versus when we don't. But it's something to consider. And obviously the power consumption that you actually use on that basis. Fans consume power, but not necessarily as much as consume power and therefore money, but not necessarily as much as blowing a power supply and having to buy a new one. So, mining pools versus individuals. I've done individual mining for a very small amount of time, and I've never actually gotten anything out of it, and so I don't. My understanding, probably the reason I've not received anything is basically because I didn't have enough of a hash rate to be able to really compete with the other guys that are out there. So I received 0. Most people that I know of have gone maybe a month or something without getting any payout, and typically don't really end up wanting to do that. Again, kind of same concept. Pool mining, lots of people, you combine hash rate that you're going to go about it. You're typically going to get more, out of that pool, whatever that pool may be. But there's a lot of pools, so which one do you use? Again, what currency? There are fees that go along with these too. So typically that's going to be like a 1%. Some of them are free, some of them are higher than 1%. And then on top of that, with Great Per, in each hash rate there, you might consider the greater than 50% or the 51% problem being that, are you contributing to somebody that you don't want to be a part of? But I don't think anybody is actually anywhere near like a 50%, so I think that's not really a problem. But so another concern, some reward like uncles and orphans, others don't. So just if you think you're going to try and make money on uncles or something, then go with that. Terms that I've had to explain over the time that I've been mining because of that. What's an unconfirmed balance? We kind of talked about this being in the blockchain. If you have like an uncle or something, if you have a proposed block that might be verified, then a lot of these will take some amount of time, typically in minutes, hours, or blocks, that they'll say, well, we're not going to award you that money. It's yours, but you're not going to get it into your wallet until we've confirmed that you actually got that block, or that we actually got that block. Fees, pay per share, pay per last N shares, I think is PPLNS. There's a lot of different fee schedules, the way that they're actually going to go ahead and pay out. Probably the two most common that I've seen are the PPS and PPLNS. But there are many others that, anybody can set this. It's in the rules that they define. When you participate in their pool, they get to set what you are essentially doing here. So, you wonder about that. Payout threshold, some of them are like 0.01 value of currency, or, nominal currency. Others are like one whole, like you'd have to actually generate one whole before you get there. Some of them may have a fee dependent on that, some of them may not. Just another thing to consider and think about. Current effective hash rate, average hash rate, and reported hash rate. On like a block explorer or on the pool that you might connect to, you'll probably see some kind of monitor based on like your worker or workers, that you'll probably see something along these lines, being that like what your reported hash rate is, as in like what they're saying we're getting like right now, and then your current effective hash rate being like this is what we're getting normalized for like the bounces up and down that you'll get like second over second, and then the average being like a longer time span that you'll see that. So if you have like something that goes offline, and this is why I've had to answer that question, if you have something that goes offline, then you'll see dips in some of these, not others, and so people that don't necessarily understand are gonna have questions. So some programs that are used. Obviously, these are also going to vary, based on what you might be using. Application specific, or ASICs might only be able to use a specific algorithm or something. The operating system you're using, if one's not built for Windows but it is for Linux, obviously you can't use it, right? If you're on whichever one, and then which one you might want to be using. Some of them have support multiple, and some of them don't. A wallet, another program that you're going to need. Just something that you're going to need. Sometimes they're separate, sometimes they're included in what you might be using. Also hardware wallets exist or like cold store wallets if you want to take that offline and not have it sit somewhere. I don't know, I guess if you have a lot of money or a lot of value stored in something, you might want to do that. So some programs that are used, that I've found, I think, are the most commonly used for these: Bitcoin, CG Miner, BFG Miner. I think BFG Miner was like built on CG Miner, and then there's like a GUI on top of BFG Miner now too. But there's been a lot of development in that area, so I'm sure that there's been a lot going on there. Litecoin, SG Miner was built on top of CG Miner, so you could use it up to a version of CG Miner, and then you would want to start using SG Miner for Litecoin or Script in general. BFG Miner also supports Script as well. Ethereum or ET Hash, so I've got the Geth plus Eth miners, or Geth and Eth miner were kind of the early versions that Ethereum used. Claymore seems to be the de facto standard in this area. I've just got an image of it, basically what they look like there. A lot of them are, just command line stuff, so it just kind of sits there and runs for the most part. One example of a multi-currency being MinerGate, and that one tries to like smart mine which one, like whichever currency has the best like monetary value in the last like hour or so. I used that for a very short time. Their fees are okay, but I wasn't like super happy with it, and I got better hash rates with Claymore, so I went to that. Oh yeah, so case design stuff, guys, feel free to take a look at this guy, come up, talk about it afterwards or whatever. Otherwise, questions on mining or discussion on mining?
If you're going to get into mining at any point, you need to do a lot of research into the miner's fallacy. Or the miner's fallacy, miner's gamble is also called, where a very simple equation, Fight Club style A times B times C times D type equation of if the cost of your equipment plus the cost of your electricity is greater than what you're ever going to possibly get out of it, and the only way that you will ever make money on mining is by the value of the currency you receive going up, and you're hitting the gamble. And
it's a gamble. Yeah. So to, I guess, add on to that point, when the first rig that we built that, was small and, didn't cost us that much necessarily, but, did cost us over $1,000. I think it was like $1,300 or $1,400. With Ethereum, took us like 9 months to get our return on investment on. Whereas at least the current pace that I've been running this guy for, I'll probably get my return on investment, assuming Ethereum stays at roughly the same value, because the value's changed so much that I'll get that in like 3 months or less. So that's a big difference, but Ethereum could go to zero tomorrow, and I could lose a bunch of money. So, but at least it's not all my money. So, yeah. Other questions? Or go ahead. Okay. So, algorithms applications. This kind of disclaimer here. So, very much, if you want to help me, speak up or something. I've done. A fair amount of like reading the white papers that they publish on these. I definitely don't think I understand all of it, and sometimes it's way over my head with the actual mathematical proofs they're doing. If you love proofs, read these white papers because they have a lot of them, or at least they describe a lot of them. So generally speaking, kind of said that we talk about proof of work and proof of stake before, so that's starting point. As best as I can kind of boil it down, if we're going to say proof of work, essentially there's got to be some kind of computing done, to say this is going to be the next block. There's, this establishes a time frame between each block and an expected time frame that actually anything's going to go based on. A lot of the time in, again, white papers, these are proven or, proven with specific hardware, so that it can be extrapolated based on, better or newer hardware. And then there's also just fun research on an algorithm might run better on Intel or AMD or whatever architecture that might be out there. So some of those are fun to take a look at too, but just if you have a lot of time. I kind of mentioned this before, multiple blocks might be valid based on these algorithm rules, and that's why with proof of work there's a time frame between you kind of getting like a verified sum, something that goes along those lines. I'm not going to put this in there, but I just want to put this link in by proof of work. Really basic explanation, kind of goes back to what we talked about in the blockchain area, but gives you kind of like a really basic demo. If you aren't sure kind of how the proof of work algorithm works, then watch that guy. So proof of stake. The implementations that I've read up on are, primarily some kind of voting or gambling stakes or form. So if you have if you can demonstrate a stake, then you can, say, I think this is going to be the next block that's going to be there, and make money on that or lose money on that. Really, I don't know a ton about this. Ethereum's been doing research on that, so that is another area of concern if you're going to mine, because if they change the algorithm that they're using, that might make your equipment that you might be mining on now worthless for that algorithm. There are a couple of them that are out there that use proof of stake, typically because you don't necessarily need any hardware for a proof of stake. These can generate blockchains way quicker. There's a couple of blockchain services that are out there that because they operate on proof of stake, they're trying to, or even like consulting firms that because they're operating on proof of stake, they're like, we can make you a blockchain of n size in days, where it took this long for Bitcoin or another proof of work based blockchain. So I'm not really sure that there's any value, that there's necessary value in proof of stake over proof of work. Ethereum's doing a lot of research in that area, which is part of the reason that they seem to be not just jumping in head first on it. But I know there's been some problems as far as guys that have, blockchains that have actually adopted proof of stake in, how either they wean off of proof of work or, just how it works in general. So honestly, again, proof of stake is not something I've had a ton of experience with, and there's there's less blockchains that use proof of stake. So.
A simple metaphor I think might be useful to share is proof of stake is, proof of work is your hash rate is how much mining equipment you have. Proof of stake attempts to essentially say the number of coins you have are kind of like your virtual mining rig. So it's in a proof of work system, the number of computers you have hashing determines your chance of being able to solve the next block. In proof of stake, it's just the number of coins you have determines your chance of being able to create the next block or solve the next block. They have different security assumptions though, because with proof of work, you have incentives that are all come into play. In proof of stake, your incentives are just to have the value of the coins you're holding not go down. In proof of work, it's that plus all the hardware you've invested in. So they have different security assumptions.
My understanding is a large motivation behind switching to proof of stake is that you won't be spending millions upon millions of dollars in electricity just to verify your transactions.
Yeah. Especially if you just want one for some kind of business application, don't really want to build that much infrastructure.
Yeah, anytime you hear somebody criticize Bitcoin or any other cryptocurrency for like, oh, it costs as much as the entirety of New York City in order to power this blockchain per day, they're making a legitimate criticism of proof of work.
I disagree, but we can argue about it.
It's a point Dan and I disagree on.
So because I don't, know a ton about the proof of stake algorithms, I don't have a ton of information on them in here, but I'm just kind of going to go over a bit of the proof of work algorithms that are generally used. I don't have these necessarily associated with currencies that are using them or anything. SHA 256 or SHA-2. So I guess, was it National Institute of Standards used to use SHA-2. I don't think they didn't move off of that because there was any collisions that I know of. There's not been collisions found. So, again, the debate could go on based on if it's still cryptographically secure or not. So lots of algorithms still use that or use it as one part of theirs. Script. So a password-based key derivation function, designed as memory dependent, although I guess in the end they found that kind of like an infinite integer or big integer, you could, because it was like a pseudo-random generated, you could seed and then use an ASIC to actually go through the algorithm and then generate the next bit that would be in place and go through that, which would just become a time-dependent function rather than it being a memory-dependent function. So time-dependent, meaning you could use a specific processor for and speed it up. Still used in some in Litecoin. X11, lots, so layered hash algorithms, 11 different hash algorithms that are SHA-2 or SHA-3 algorithms here. Sorry, S-script. I've been pronouncing script for a long time. But S-script. So SHA-3, as I mentioned, NIST moved on from SHA-2 as the standard, but just the competing priority there. Blake, another, because a lot of these have been developed while SHA-3 was coming out or being finalized and proposed, there are other variants that have been used in between or have been even developed actively on by different groups, Blake being one of them. I guess Neo S-script would be the pronunciation. They were actually able to prove that this was memory dependent, so not significant or a ton of memory was required for it, but more than just a CPU could provide, so or a cache could provide. So some kind of GPU or some kind of like heavier ASIC would have to be used with these. ET-hash. Being developed also with the SHA-3 standard, they actually implemented some changes. So it's not 100% the same. That's why I'm mentioning based. but they also use the Dagger Hashimoto or DAG data structure, which uses way more memory, and to the tune of like gigabytes of memory rather than like Neo script or script used something like megabytes. I think the maximum in like a relatively large was like 700 megabytes or so. So still something that you wouldn't have on a CPU, but you would have on a graphics card. Equihash. So this one's actually really interesting to me. Just as I have read through the white paper. So their white paper is cool to read, but it being asymmetric, I don't fully understand really the usefulness for that, but the like provable memory hardness for that based on like the birthday problem that they're using was, I don't know, interesting read. I haven't mined anything that's based on that, so. ASIC resistance, the concept of being basically if something's like a memory hard or requires some kind of memory, then it's kind of hard to produce like just a processor that's going to run everything on it. And so like rigs are kind of typically going to be used on algorithms that are some kind of like ASIC resistant. Obviously, as I mentioned, if they were to move to proof of stake, it doesn't really matter anyway. So yeah. So applications, literally and figuratively, being that like some applications that are being developed on these platforms, the most that I know of are based on Ethereum's platform, smart contracts and in their Solidity language. I haven't written anything in this, but there's like a dApps in like the last page.
What's a smart contract?
So I don't have a full understanding of smart contracts. The basis that they're providing is like that you can like make a transaction between each other and have some kind of like contract value. It be the contracts what they're for. I don't know, but yeah, I don't know.
So one way to think about it is that all contracts in the physical world are code. They're just written in a particular manner that only the interpreter that is the court can actually divine what it means and actually execute it. Smart contracts give you a lot of the same tools that contract languages do, in that you can say this thing, or really this token, passes from this person, this address, to this person, this address, only when all of these conditions have been met.
Got it.
And you can define those conditions in Solidity and other languages that are built on top of Solidity.
They essentially built a virtual machine on top of Ethereum that executes an intermediate language on the blockchain.
Yeah.
And it uses as inputs to the execution of the contract the constantly changing state of the Ethereum chain.
Also, apps, dApps, I don't know. I've just looked at a lot of these, wondering, what's out there. It seems like a lot of them are, either cryptography related, voting, messaging, smart contract based, which I don't have a ton of, information about what their usefulness would be. A couple of games that I just saw really like word games that were out there, but I don't know, some fun stuff that's there. If you're interested in participating in developing in something, I guess Ethereum is a viable place to do that. I'm not really sure if there's anywhere else to do it, honestly, because I can't really find anything. So
They do have 3 good tutorials on the Ethereum website that can just walk you through the steps on how to do it.
yeah, so there's I did like the getting started one, and that I've got a link to in there in the last page too. So if you guys have there, but I would just go to ethereum.org and you can find it pretty easily too. But yeah. Other applications, I guess really kind of more like the current future applications as far as like what it might apply to, rather than, as it being a foundational technology, rather than like, specifically like applications that you might be developing on something. So this is kind of more like products. I mentioned IBM's blockchain on Bluemix, their virtualization. Like I said, lots of consulting firms that are, trying to do something for people. Exactly what seems to vary, widely on what they're trying to consult for, or maybe what project they get involved in. Microsoft's blockchain as a service on Azure. I just kind of back up to secure application development with Ethereum, because honestly, in the end, somebody's going to develop this stuff, and I haven't yet. Some of you guys maybe, if you want to get started. So yeah, that's pretty much it. I have posted materials up there if you guys want these. If you want to contact me, if you know less than I do and want somebody to talk to, then I'm on Twitter. Send me an email, or shameless plug for myself. Check out my website. That's all I've got. Otherwise, open questions.
So the argument kind of that proof of work is a waste of effort on mining, have there been anything that you've seen that's like trying to do something productive? Like I remember you used to be able to run SETI at home and protein folding and things like that to do productive work while your computer's just idling. Is there any, proof of work that could do something like that?
I mean, people definitely use like a otherwise idling device as some kind of value. I mean, typically you're going to have to using a proof of work algorithm, you're going to end up using more electricity. So it's not really that like it's no longer like a direct idling where I was using the same and now I'm just using that where it wasn't being used. You're going to end up using more electricity, therefore more resources, therefore money of somebody's, right? So I don't know that I've not heard any argument that says like just because it was idling, then you're going to end up using more or less. I feel like that would be a hard one to make, but you seem to be the proof of work argument.
There's been attempts at doing that. I think there was Cunningham Chains, one of them was doing something with those, but the problem mainly being that proof of work takes as input information from the system itself. So it's taking transactions from the actual blockchain system as input. And so if you're trying to, do protein folding or something, the input for those problems is not, they don't have anything to do. You'd have to combine that problem solving somehow with inputs from the system itself that are operating in, and that doesn't really work.
I would like to mention one project. Are you familiar with Golden?
I do.
Yeah.
I learned a little bit about
So it kind of related to what you were asking, where essentially you use excess processing power to perform tasks that can be distributed easily, such as rendering matrix calculations and things like that, and they pay you in GNT for your processing time.
Cool. Anything else? Okay. Like I said, a bunch of links that I've come across on my favorites or something. So include in there if you guys want. I'll just leave this up for a minute, then I'm done.